Any questions on 1? .1, any questions on 1 or 2? 3, 4, 5, 6, 7.
Yes.
Both parts?
Yes.
Okay, remember, coterminal angles mean you either add or subtract 360 from it. So for 7a, we're starting with a negative 420. So if I add 360 to it, what do I get? Hello?
160, negative 160. No, negative 60.
Okay. If someone can bring it down when they get a chance. If not, I have calculators in the classroom. Thanks, bye. So what's negative 420 plus 360? Negative 60. There's a negative coterminal. If you add 360 to it again, what do you get? 300. There's a positive. You say B2?
Yeah.
So B is 230. Subtract 360, what do you get?
Negative 130.
Negative 130 degrees. If you take the 230 and add 360, you get 590. Questions on that? What about 8? What about 9? On the back, 10 through 12.
11.
Convert 87.4 degrees to radians. How do you convert degrees to radians? Multiply it by pi over 180. So in your calculator, you do 87.4 times pi, divide by 180.
Question 7, why didn't you add 360 to negative 130 like you added it to negative 60?
Because if I added 360 to it, where's it going to take me right back to? It'll take me right back to the original. This one here, because it was already negative, I added 360. I have to keep adding 360 to get to a positive angle. Because I was a negative less than 360. 1.525. And it says round to 3 decimal places. This one was one where you just had to put it in your calculator and do the math. Any other questions on 10 through 12? 13 through 15.
13.
Yeah, I'll say 13.
Has an intercepted arc of 6 inches. What's the formula for that? It's in our notes.
180 over 5.
Yep, it's SR theta, but right here, it's S equals R theta, but what's important about it? Theta has to be in radians. Okay? Theta has to be in radians. So find the radian measure of the central angle with a radius of 27 and an intercepted arc of 6. How do you solve for theta?
Divide by 27.
Divide by 27. And these are both divisible by 3. So theta is 29 radians. Is that the answer I gave you? What'd I do?
2 pi over 9.
That's what I wrote for the answer, 2 pi over 9.
No, it says 29 radians.
Okay.
You're right.
Yeah, radians don't necessarily have to have a pi in it, guys. Like up here, we did 11. We did 1.525, and it was radians because we multiplied it out. They wanted us to multiply it out. Down here, when we solve, if the pi is, if they gave us the radius as 27 pi or the intercepted arc was 6 pi, then yes, we'd leave the pi there. But there's no pi there, so it's just 2/9 radians. Radians will not always necessarily have to have a pi in it. Other questions? 14 through 17. All right, what about 4-2? Questions 1 through 8. Connor?
You do number 1.
Number 1. What was the answer to that? I have a feeling I had a typographical error there.
0.707.
Oh, so number 1.
Yeah, what did I give you?
Square root of 2 over 2, square root of 2 over 2.
Yeah.
Oh, never mind.
Okay, so that probably number 1
I was confused.
probably was supposed to be pi over 4. Because it says it's on the unit circle. All right? So find the point xy on the unit circle. You guys took that stuff home? Huh?
No, I didn't.
You did?
No, I didn't. I didn't take it home, but Brandon had it.
So this is on the unit circle. So a typographical number 1 should say pi over 4. So that point on the unit circle is square root of 2 over 2, square root of 2 over 2. Any others on that 1 through 8? Nine through 14. Fifteen through 18.
18.
What I'm going to do is I'm going to write this as a mixed number. 8 pi over 3 is what as a mixed number?
2 pi, 2 over
2 2 2/3 pi, right? So we're rotating a negative 2 2/3 pi. So here's our unit circle. So I need to rotate a negative 2 2/3 pi's. So I start here, and if I rotate 2 pi, where do I end up?
Right back.
Right back where we started from. And then where's 2/3 pi? Well, here's 1/6. Here's 1/3. Here's 2/3. So it's right here. And we're looking for what? Which one? I'm doing cosine. So which one is the cosine value of that ordered pair?
-1/2.
-1/2. So we rotate this way. There's negative 2 pi. And then 2/3. Other questions on 15, 16, or 17? 19 or 20? Okay. From our notes. Right down here, we have the fact that sine of negative t equals negative sine of t. What they ask us to find, use a value to evaluate A, sine, B, cosecant. So from this, if I put in 3/8 for that, it equals a negative sine of t. So what does sine of t equal? Negative 3/8. And what does cosecant equal? They're reciprocal trig functions of each other, so negative 8/3. All right, so we're dealing with cosine. The identity says that the cosine of negative t is equal to the cosine of t. So what does the cosine of t equal? Negative 3/4. So what does the cosine of negative t equal? Cosine, negative 3/4.
This is what we have to memorize for our quiz tomorrow.
No,
Let's check that I use.
let's get through this, then I'll go to that, okay? Because I'm recording this, and then I'll add. That's okay, but we'll go through that. I'll remind you, but not these yet. So then secant of a negative t equals secant of a positive t. So if cosine is negative 3/4, what's secant? Negative 4/3, which they're equal, so it's negative 4/3. through 30. Any questions there? This was a matter of just putting them into your calculator, and what mode should you have been in? Radians. These are all radians. You know, number 26, 27, 28, 29, those look like they're degrees, but they don't have a degree symbol in them, so you have to assume they're radians. Questions there?
You do 23.
23? Let's give me a calculator. Okay, 23 is finding cosecant of 1.3. Cosecant is not on this calculator. I'm in radian mode. So cosecant is a reciprocal of what?
Or
Sine. So I have to take 1. So on your calculator, you're going to go 1 divided by sine of 1.3. I always close my parentheses just to make sure. You get 1.0378. Okay? Any other questions? Four point three. One, 2, and 3. I had a question through email yesterday, and it says sketch a right triangle corresponding to the trig function of the acute angle. Use the Pythagorean theorem identities to determine the third side. Oh, use Pythagorean theorem to determine the third side. Then find the other 5 trigs. So I guess any questions on 1, 2, or 3? 3. So I'm going to draw my triangle. I'm going to put theta here. Doesn't matter where you put theta. They tell us that cosecant is 17 over 8. So if you remember, so Katoa,
17 over 4.
thank you. Thank you for not letting me work the whole thing wrong. Cosecant is a reciprocal of which one? Sine. So cosecant is 4 over 17. I'm sorry. Cosecant is hypotenuse over opposite. So that means that 17 is my hypotenuse, 4 is my opposite. So 4 is opposite, 17 is hypotenuse. How do I find this value here? This is going to be 17 squared minus 4 squared. Someone do that for me in the calculator, please. What's 17 squared minus 4 squared? 273. This one will rationalize some more. 273 divided by 4 is what?
68.25.
Yeah, I don't think you can.
I have divided by 3, sorry.
You have to leave it there.
Yeah, you have to leave it.
It's
The
91.
answer has 273.
Does it? Okay, thank you. All right, so this is square root of 273. So then I got to find the other trig function. Sine, cosine, tangent. Sine is opposite over hypotenuse, which we know that already by just doing the reciprocal of this. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And probably my answer said this. Is that what my answer said?
Yep.
I was at a conference yesterday, and through that conference, the lady from the state wanted to know, why are we rationalizing denominators anymore? We have calculators to do it, to get them out. And so I'm going to tell you that from here on out, I'm not going to make you rationalize the denominators, except my answers are going to be with the denominators rationalized. So on a test or quiz, if you don't rationalize, I'm not going to take points off for it. And I'll get things adjusted.
So like if there's a square root on the bottom.
You can just leave it. Mm-hmm. Go to calculus, I let you leave a square root in the denominator. Go to college, we let you leave a square root in the denominator. So it's not an Indiana standard anymore. So, and then we need secant, 17 over square root of 273. If you want to check your answer, there's what you get. Cotangent, reciprocal, square root of 273 over 4.
This one, can I go to the bathroom?
Four, 5, or 6.
What did you say?
4, 5, or 6.
5, 6, 7, 8.
Wow.
I said 4, 5, or 6.
5 and 6. I don't know what I'm doing.
All right, so here it says use the identities to find the answers. A, sine of theta. B, cosine of theta. C, tangent of theta. D, secant of 90 minus theta. All right, well, what's sine?
Opposite.
Not opposite.
Reciprocal.
Reciprocal of cosecant. So that's just 2 over the square root of 13. Which I probably on the answer sheet said 2 square root 13 over 13. Cosine is reciprocal of secant, which is 3 over square root of 13. Tangent is what?
Opposite over adjacent.
Sine over cosine.
It is opposite over adjacent, except we're using the trig identities since we didn't draw our triangle. And we're going to use tangent is sine over cosine. So tangent is sine, so that's going to be 2 square root 13 divided by cosine 3 square root 13. Multiply by the reciprocal. Square root 13's cancel, and you get 2/3. And then secant of 90 minus pi from our notes, that's equal to cosecant. From our notes. Cosecant of 90 minus theta is equal to Okay, we got secant, sorry. Secant of 90 minus theta is equal to cosecant. It's in our notes. So this just equals square root of 13 over 2. Number 6. I have cosine. It's the only one they give us. Well, what's secant? It's reciprocal cosine, which is 3. Next one they ask us to find sine. I only know cosine and secant. How am I going to find sine? And in the directions it says use the trig identity. So on the back of that circle, unit circle, you listed how many trig identities did you put on there? 11. Those are the 11 that's going to be on your quiz tomorrow. And so of those 11, which ones of those contains a sine and just a sine and a cosine?
Well, sine squared and cosine squared equal 1.
Equals 1. So that's the identity you're going to use. So sine squared. Well, what's 1/3 squared? 1/9. So we got to subtract 1/9 from both sides. That's 8/9. Square root it. Square root of 8 over 3, which is 2 square root 2 over 3. C says cotangent. Cotangent is cosine over sine. Cosine is 1/3 multiplied by the reciprocal, which is 1 over 2 square root 2. I think you get square root 2 over 4.
Yeah.
If you want to check the answers, you can leave it like that. Then from your notes, sine of 90 minus alpha is the same as cosine, which is 1/3. Questions there? All right, 7, 8, or 9. I'll do one of them. Multiply 9 out. distribute it, FOIL it. Any other questions on 7 or 8?
That's what I did.
Says make the left side look like the right side. After we're done graphing, we're going to spend a lot of time making the left side of these trig identities look like the right side. First trick of that you put in your bags of tricks is change everything to sine and cosine. It's the first thing you want to try to do. So what can I change here? I already have a cosine, but secant is what? It's 1 over cosine. What happens over here?
Cancel out.
They cancel out, and what are we left with?
1 over 1.
1 over 1, which equals 1. 8 is the same exact problem. I'm going to do number 9 because number 9, these type of problems are going to show up a lot in the identities, and it's important you understand it. If you see something and they want you to take one side and look like the other, multiply the side out if you can. So when I multiply this out, this is the same as a plus b times a minus b from algebra. And when you did this, that was a squared minus b squared. You will use that a lot. So 1 plus sine and 1 minus sine is going to be square the 1, you get 1. Square the sine, you get sine squared. From this Pythagorean identity, if I solve this, if I subtract this over, look what happens. That cancels, and cosine squared theta equals 1 minus sine squared theta. So whenever you see 1 minus sine squared or 1 minus cosine, your brain needs to go to this Pythagorean identity. 1 minus sine squared is the same as cosine squared. All right, we're going to stop there.